Okay. I'm gonna open this on my iPad and see if this works. Let me look at bear with me for a second. I don't know why this is this. Sorry, I'm trying to figure out how to streaming for the first time, so I'm trying to do this as I go. Okay. Alright. I actually just straight up forgot the name of my channel. It's been a while. Okay, I'm gonna try getting rid of this. I'm gonna see how this works. Okay, I think that works better. Sorry, it's so delayed. I'm watching on my phone right now to see how it looks. It's kind of whack. Okay, let me zoom out here so you can see the whole page. Hopefully this works. I can't really show my iPad screen at all, or at least haven't figured out how to do that. So I'm kind of unsure how I'm going to show how I learned this. I'm going to have to just kind of talk through it. Okay, my thing is so delayed. It's like 17 seconds behind. Let me see. It still isn't lined up right, and I don't know why. I'd like it to be a little better. Is this gonna work? Get rid of OBS. Okay, I don't know why this is not working. I don't even know if I'm able to do anything today. It's just gonna be me figuring out how to work how to live stream. Mathematician tries streaming for the first time. That's what this title should be. I'm literally live doing this. I'm just looking at my phone. Maybe this? I'm trying different things to see if it'll work. Oh wait, I had it. Did I mess it up? No, it doesn't work. Okay. I don't know why this doesn't freaking work. Okay. I had it. There was one. I had it at one point. I'm gonna try putting it here. In the meantime, I'm gonna go to my physics thing here. Okay, hold on. I think I'm almost there. I think I need to just zoom out one more time. I think this might be it. I think it actually has everything in the page there, but I'm also gonna edit where my head is a little bit. I think it's fine. Okay. We got it. We got it. Okay. Alright. I'm going to keep this open on my phone, but I'm going to turn the volume off. Just in case anything happens. This is a super fun stream. Okay. Turn the volume off on this. I'm gonna bring this here so I can see what's going on. Oh, my OBS is in the way. Alright, you guys can see my editing. Okay. So, let me... My desk is a mess. Luckily, you guys can't see that. Okay, so welcome. I don't know how long that took, like 5 minutes or something. I don't know if I haven't really posted anything in a while, and I only posted a few things, and I would say the quality was maybe not the highest. But I wanted to try something new. I wanted to try sort of a live study situation. I saw Andrew Dotson do this a little bit ago with string theory, and despite me being a fan of Andrew Dotson, I don't know the first thing about physics, pretty much. I only took physics in high school, and ever since I hadn't really touched it, and it's been something I always wanted to study, but for some reason or another, I couldn't. And now I'm waiting for my PhD to start, and I kind of have a little more free time. I'm still doing research with one of my professors from my master's program, but I figured when I have this time, I should try learning something that I've always wanted to, study. So, this is Taylor's book, Taylor's Classical Mechanics. Admittedly, I'm a little bit worried about, I don't want to be I don't want to have any copyright infringement. Admittedly, I'm a little worried about that. We'll see if it's a problem. I don't really think being as small as I am, it should be that big a problem. If it becomes a problem, then, that's a different story. But I found this on Safari. It's open. This is available to the public, so I can't imagine it's that big a deal. But if there's a problem, then I'll take this down. I won't continue doing this. Or I'll do it without showing the book. But I think the book is helpful. Now, as a little bit of pretext, I've already gone through the first chapter on my own, and I went through some of the problems here. The first half of the problems are pretty much just linear algebra. Honestly, not gonna lie, some of them got me. Some of them got me. It makes me a little bit concerned of my linear algebra knowledge, but it wasn't questions about vector spaces or anything like that. It wasn't something about vector spaces or anything like that, but it was basic linear algebra that it's getting me a little bit. So I'm a little bit nervous about that. But anyways, we're gonna continue, and we're gonna go into the Newton's second law and Cartesian coordinates part. And this, again, I already read through the first chapter. I'm probably gonna have to reference stuff because it's been a while since I looked at this. But I figure I have another 45 minutes I could look at this for. So let's do a few problems, I think. And I think it's maybe a little bit cool to see how a mathematician, a quote-unquote mathematician, I don't know if you can I call myself that. I'm not even, my PhD program is in applied math, not pure math, so I'm very reluctant to call myself that. I probably should call myself an applied mathematician, which I'm really not still. I don't have my doctorate, but whatever. We're going to try doing this. Hopefully we can figure some of these questions out. And maybe you could see, for those physicists out there, you can see how a mathematician thinks. I don't know if it's going to be helpful coming from me, because I am not exactly a model mathematician. But again, we'll look at this together, and we'll see what happens. All right, enough of the whole spiel. Let's get into some of these problems. All right, so we're going to start with 36. I did 35 already, which I couldn't figure out on my own, not gonna lie. Okay, but this one, we have a plane which is flying horizontal, and that's, by the way, that's bad. It took me, I had to whatever. Anyways, 36. A plane which is flying horizontally at a constant speed v0 and at height h above the sea must drop a bundle of supplies to a castaway on a small raft. A. Write down Newton's second law for the bundle as it falls from the plane, assuming you can neglect air resistance. Solve your equations to give the bundle's position in flight as a function of time t. Okay. So, this is where I think my lack of physics knowledge kind of gets me here, because I don't remember how to do this really very well. I'll mention too, physics was definitely the hardest science STEM class I ever took for me. It was definitely always the trickiest. Okay. So we know we have F dot is equal to M times the second derivative of the position. So they call it F dot is equal to MR double dot. And there are three components that go into this. In the three-dimensional case, there's the force. Wait, did I say F dot? It's not F dot, just F. Oops. Okay, so that's equal to the force in the x direction is equal to mass times the second derivative of the x position. And then the same thing for the force in the y direction, and the same thing for the force in the z direction. Okay, epic. So if our plane is flying horizontally at constant speed, then it has... So we know that the x direction has no force. It's operating at a constant speed. Okay. I mean, that makes sense because so in other words, v0x is equal to, well, 0. Well, okay, hold on. Let me write this instead. Vx, no matter what, is equal to v0. And the height is constant as well. But that's the y position. So the actual velocity in the y direction is 0. Okay. It doesn't move in the z direction at all. Okay. Let me try to think about this. No. The y direction's not constant. Okay, I think I got it. So there's three equations of Newton's second law. In the case of three dimensions, there's the x direction, the y direction, the z direction. What I just wrote down was the direction for the plane. We want the crate. Sorry, the bundle. Now, if we have, so let's do f, like the equations for f bundle. I really wish I could show my screen. I'll figure out a way to do that next time. For f bundle, as a function of phi, which it is because. Okay, so this would be fx equal to mx double dot. I think that's 0. I think f of x is equal to m times 0, which is equal to 0. I don't think there's any force. If the plane is moving at constant speed v0, and there's no air resistance, then if you drop the supplies, they should also move at v0. Because there's no air resistance, there's nothing affecting that. So the force in the x direction is 0. If this is so excruciatingly slow for you, it's because you're much smarter than I am, which isn't saying. Unfortunately, it's not saying much because I'm very challenged. I feel like. Okay. So that means the force in the y direction. Well, it's whatever the mass of the bundle is. Does it say the mass of the bundle? No, not yet, at least. Okay, the mass of the bundle times. Now this should accelerate. It should be times whatever gravity is. But we're going down in the y direction. Right? It's the initial. God. Okay. Hold on. I'll figure this out in a second. I'm gonna try to use calculus. Let's just do fz because fz is 0. I mean it's mass times 0, which is 0. Okay. So fy we don't know. So how can we find fy? Well, okay. The position. We can look at the position vector. dry dt. What is our function? What is our position? Well, no, we don't know that. So we know our acceleration. So we could integrate to find it. So d a y. No, I cannot. Okay. A y. Now it's accelerating down. So it'll be negative g. Is that correct? I feel like this is going to involve trigonometric functions. This whole live stream is going to be me solving this one problem. Excuse me. I'm very confused. Okay. I feel like this has to be right. Now, AY... Okay, I think the acceleration's right. I think it has to be negative g. Which would make the velocity of this equal to... We just integrate it, so it's negative gt plus some constant c0. And then we integrate it again, and that gives us the position, which would be negative gt squared over 2 plus c0t plus c1. We only have one initial condition. Well, no. It has to eventually go to 0. So we know final time t. Okay. Using initial condition. Using initial condition, we know, well, C1 has to be H. We have Ry0 is equal to H. This gives us so yeah, plug in 0, that means we have negative gt squared for 2 plus z0t plus h as our position for the height for the position of y. But then at final time t, whatever our final time is, we know what should I call it? But do I need to be any more specific than this, I guess is my question? Because we know at final time t, the position will be 0. So we could plug in t0. Let me try that. So if we have ry of final time t that's equal to 0, negative g capital T squared over 2 plus c0 capital T plus h. So that'd be negative. So we have negative h is equal to, the c0 is going to be some, okay, it's going to be some function of the final time t. I don't know if they expect you to put the final time / I don't know if we need to, but we need to, I guess we need to define what that other constant is though. Oh, you know what we do know though? We know the initial speed, the initial velocity should be 0. Okay. Okay. So then, if v z0y is equal to 0, so if we have v y0 is equal to 0, then we have vy0 is equal to c0, which is equal to 0, which means that which means that c0 is equal to 0. Let me just make this a little more explicit. So negative g of 0 plus c0. This means that c0 is equal to 0. So our position in the y direction would be negative gt squared divided by 2 plus h. And this makes sense because we're going to be getting closer to the ground exponentially as time goes on. And if time's 0, then our height is h. I think that makes sense. Because I think that makes sense. Okay. So let me put this on another page here. So we have our equations of motion are I don't know about that. I know z. Z is definitely 0. I have one for y. So we have fy. Oh no, I don't need this. So we have, let me write r instead. So we have r t is equal to x of t, which is equal to think about this. There's no air resistance, so it should just be v0t. No. Oh, I got this. So x position. Okay, so this would be x. So we know the initial velocity. So we have vx of t is equal to v0. That's a constant, which means that our r position is equal to v0t plus some constant z0. And at time we need to know what that constant is. I mean, we could just assume it's 0, right? Okay, then I think its position is initial velocity times t. Which makes sense, because we're just assuming the first position is 0. So then our equations of motion would be I'll change it to rxt. We have xt is equal to v0t, yt. It's a little more complicated. It's equal to negative gt squared over 2 plus h, and then zt is just 0 because shouldn't be shifting. I feel like that's right. I don't know if we need to express it in 3 separate things. I'm gonna check the answer. I do have an answer key, so I'll be the first to admit that. I'm gonna have to fix this again, aren't I? Hold on, I want to see how this looks on the screen. Okay. I don't know why it doesn't just fix on the... Yeah, okay, it gets in the way. I think here it's fine. I don't know why this doesn't work. Okay. I haven't really been checking chat either. I don't think there's anyone in there. I don't know what's going on here. We've been working on this for way too long. Okay, I don't know what the hell's happening. Try just exiting out of that and opening this. I'm trying. As this is pulling up, I'm trying to think how this is wrong. Oh, my computer's really going at it right now. All right, forget that. I'll try playing up on here. Need to go in here. Sorry. Oops. You couldn't see if someone joined. I thought I saw another face, but I don't know if that was just my account again. I need to see if I did it right. Okay, let me try looking this up. I don't know why I can't find the solution manual. Bear with me. I want to see if can I look at chat? It's buffering. Okay, that's fine. I think there kind of has to be buffering. Don't know what's happening. Is there just a PDF I can get? What? Okay. I think I almost got it. Maybe not, because this is... I don't know if this is the same edition. Okay, this is correct. Feet. Oh! I got it right. Okay. So it is a function of two variables, and the x position is the initial velocity times time, and then your y position is height minus your minus whatever gravity is times t squared over 2. Oh, okay, I got it right. Let's go. All right, part B. This is all going to be me answering one question. How far before the raft must the pilot drop the bundle if it is to hit the raft? What? Okay. Well, how far before the raft? So let's just say the position of raft is, it's going to be r sub little r is equal to, well, let me write this out because I'm going to look back at this probably. Let position of raft be, have there been any chats here? No. I'm keeping the chats open on my phone. Okay. Position of raft be r, which is called r. We don't need it as a function, I don't think. No, we do. It's the raft will be, it's r. What do I call it? The raft. I'll just write out raft is equal to. So the position will be horizontally whatever r is. Oh no, no. We just need to see where. Hold on. Okay, so we need to see where it's gonna drop. Okay, so we just need to see when the y position will be 0, and then look at the time, and then see how far x goes. Okay, so the bundle will hit the raft when yt is equal to 0. So we solve for this time. So yt is equal to 0 means that we have negative gt squared over 2 plus h is equal to 0. This means that we have, just do the algebra very slowly, negative h. So we have that t squared is equal to it'll be 2h over g. And so can't have negative time, so time will be square root of 2 times the height over whatever gravity is. So that's the time. That's the time it'll hit 0. So if it's going to hit the ground at 0, we want our position to reflect that. So evaluate x at square root of 2hg. That's just, just the initial velocity times square root of 2h over g. So this is when, circle the other answer too. So that would be, it's just initial velocity times square root of 2h over g. That's when you'd want to drop it. Oh, sorry, that's how far before the raft you want to do. I don't know if you measure that negatively, but I think that's right. Let me answer the second part before I continue, because this is stuff the same question. So the distance, what is the distance if that, and that? Okay, I'm assuming my answer is valid. So if, because all the variables I have are part of that. Okay. So if v0 is equal to 50 meters per second, h is equal to 100 meters, and g is about 10 meters per second squared, then we have x of square root of th over g is equal to, so it would be 50 times. I'm not used to looking at units because in math we don't really use units. But I think this makes sense because we have meters per. So it's 2 times 100 meters. This looks like it's going to be a nice answer. Divided by 10. Oh, maybe not, actually. Is that right? I'm thinking units. So this is meters over meters per second squared. So that would give me, the meters cancel out. And then we have 1 over, so if this square root, that'll become 1 over a second. Yeah, I think that works. Because meters cancel, we have 1 over, wait, maybe not. No, 1 over s, meters per second squared. Yeah, because, yep, that works. Okay. The units work, at least. So this is 50 times square root of 20. And I'm not going to simplify this. I'm just going to calculate it. Oops. 50 times square root of 20. So we have x of square root of 2hg. It's approximately 223.6068 meters. Need to make sure I write those units because they now matter. They have not mattered for the past 3 or 4 years for me, but or like 5. But they matter now. Okay, let me see if I got that right. Yes, and yes. Okay, that is correct. Now the final part, and then maybe I'll end the stream. This stream is more of just an experiment. See if I can actually do this. And it turns out I really can't because I don't have my iPad screen. What I could do, I wonder if I could do it on Zoom or something. I feel like that's such a bad idea. I feel like my computer can't handle that. Okay, now what's the last part? Within the interval of time, plus or minus square root, plus or minus delta t, must the pilot drop the bundle if it is to land within plus or minus 10 meters of the raft. Okay. So am I doing this with the assumed knowledge, or am I doing this, let's do it assuming we don't know what h and g are. Okay, let me think about that. So to get within what interval of time? Okay, if we want to land within 10 meters of the raft, so our position is this. If we want within 10 meters of that, we'd want in what interval of time must the pilot drop the bundle if it is to land within plus or minus 10 meters of the raft? Okay. So if we want that, it's plus or minus whatever we did here. But it's a function of t. Well, can we just solve? Like we have x of square root thg plus delta t is equal to v0 times square root of 2hg plus delta t. We want this to be 10 meters. So we just solve for delta t, and this should be symmetrical. Let me see if it'd be symmetrical. I don't know if it would necessarily. Okay, so we have, let me just expand this. We have v0 square root of 2hg plus v0 delta t is equal to 0. Now we have v0 delta t. Actually, we can just get rid of v0. We don't need v0. The initial velocity actually doesn't matter in this case. And we have, oh, I'm an idiot. Yes, it does. It's not 0, it's 10. Okay. Now, we could divide by v0. I don't know why I didn't just do that before. We do that instead. So we have 2 square root of 2hg plus delta t is equal to 10 over the initial velocity. And then our delta t is simply 10 over our initial velocity minus the square root of t, 2h over g. And if it's a negative, it's not going to be just divide, it's the same thing. Okay, I think delta t is 10 over v0 minus square root of 2h over g. I'm not as confident in this one as I am previously. Okay, well, they put in numbers, so I don't know if this is right. They definitely did it a different way than I did, but I'd like to see if my way works. I don't think it does, though. Because this isn't 0. 2 over 100 divided by 10. No. Oh, whoa, no, that is very wrong. Okay. Okay, the way they do it is interesting. I probably wouldn't have done this, to be 100% honest with you. So the x position is simply, so you know that xt is equal to the initial velocity times t. So change in position is equal to v0 times change in time. And then so our change in time is equal to our change in position over our change in velocity. And our change in position is plus or minus 10. So our time will be according. Plus or minus 10 meters over 50 meters per squared. 50 meters per squared? 50 meters per second. And that gives us plus or minus 0.2 meters, seconds. Okay. That part's right because I just looked at the answer. All right. I'm gonna end the stream here. It was kind of a long stream to answer one question, but now I feel like I know how to do streams in the future. A lot of this was just me figuring out how to stream. So I'm going to end it here, and next time I'm gonna hope I can. What is this? Oh, I'm discovering things. I can. What does the lock do? If I move this, does it stay? Or is it... I'm figuring out how to what this stuff means. Alright, I guess it locks it. Then what happens if I unlock it? I unlock it, then I can move it. This is so unprofessional. No, it doesn't move. So if I move it all the way over here. I'm really confused. I'm watching myself do this. But yeah, I'd like to next time figure out how I can put this in there. Put my iPad on there. Okay, I don't think moving it changed anything. Okay, well, I think I'm gonna end it here. No one, I think one person may join in the middle while I was figuring something out with the solutions. But I don't think anyone joined. So you'll be viewing this as a video. I think I'm gonna publish it. You guys will see how much I suck at physics. Alright, well, if you guys tune in, thank you guys for watching. I plan to do more of these. Next time, hopefully we can do more than one question. And a lot of this is just me figuring out how to stream. And I still have a lot to learn, definitely. I'd like to figure out how I can put my... Next time I want to see if I can figure out how to put my iPad on the screen. But I don't know if I'll be able to do that. But I'll see. I'm going to try some stuff. And if I can't, then maybe I'll find some alternatives. Maybe I could do... Like, I use a whiteboard, maybe? You know what? Screw it. Let's try it now. I don't know if this is going to totally... Like, if my screen is going to get ruined by me looking for this. There should be a whiteboard. Yeah. Yeah, it does. It does interrupt. Okay. My stream is so far behind that I can't even see. Okay, so if I can write... Like, it'd be nice if I can... Oh, wait. What is this? No, this is just the background. See, it would be nice if I can... I'm figuring things out right now. Okay, let me, first before I even do this, let me see if I could pull up a whiteboard here. So can I add a source? It's display capture. And I want it to be... Okay, well clearly that doesn't work. I don't know what's happening. Oh, my whole thing's ruined now. No, get rid of this. How do I delete this? Yes, get rid of that. Okay. How do I do this? Window capture, maybe? Window capture. Whiteboard. Okay. I want this to be... Here, maybe? Let me see how this looks. I need to wait like 5 minutes for this. Alright, this is Mathematician figures out how to stream. Okay. So I have... That's great. That's great I have this, but... Okay, why can't I... Hello? Alright, well now it's not letting me... Maybe I wasn't clicked in here? I don't know why the whiteboard's not working. Okay, well, let me do that for some reason. Or I can draw. Sometimes. It's very delayed. What does this do? Oh, it just adds it. Yes, remove the current page. Like, if I can kick my Apple Pencil to this... Let me look up to see if I can do that. Oh, this is gonna... Oops. I think this is gonna get in the way. Let's shrink this. Okay. I really need a bigger monitor, I guess, if I want to do this. I'm looking up how to use an Apple Pencil with a computer. Okay, for quick drawings... Let's be inserted into a document. What? Sidecar. Yes, I feel like I tried this already. Click the plus menu and select the iPad from the list. I tried this, it did not work. Okay, I'm gonna get rid of this whiteboard here. I don't think this is what we want. Delete that. Alright, the whiteboard should go away now. Why is this not working? I need to log into the same Apple ID. I feel like I am. Am I gonna be doxing myself? My stuff is right here. I'm signed into my iCloud. Well, he's not signed into my iPad, maybe? I think I am. What's this? Stage manager on. I don't know what that means. Maybe, okay, I'm gonna try one more thing before I end. I wanna just figure this out now. Can I plug this into my Mac? And we'll recognize it then. Excuse the close proximity of my tab to my computer. There's definitely Hold on. I need to come around the other way. Hold on. Actually, I'm just going to turn myself off quickly. Turn that off. Okay. I should no longer be visible so that I don't dox myself right there. Okay. So let me try this. God, I have so many things plugged into this computer. Okay, now if I plug in this, I wonder if this will do anything for me. It's not even recognizing it. Maybe I'm not signed in the same ID. Something has to be off here. Mm-hmm. Okay, I can't figure this out. I'm gonna do this later. Alright. Oh, whoops, wrong thing. Okay. Thank you guys for coming to watch. Sorry, it was kind of a crapshoot trying to figure out how to do all this, but I'm learning. I think next time, hopefully, I'll have the iPad set up so I can simultaneously do my work as I talk about it instead of me just saying what I'm doing. But I think it was worth a try. All right, I'm gonna head out. Thank you guys again, and I'll see you later. Bye bye.